Hello everyone, and welcome to Lab 1. This is an introductory lab intended to familiarize you with some of the components and functions you will be using throughout the rest of the semester. Today, we will be building a simple circuit featuring an Arduino, LED, and a button switch. You'll be using the Arduino unit for most of the other labs throughout the semester. It allows you to develop interactive objects. It can take a variety of inputs such as switches and sensors, and it can control a variety of other objects. An LED, or light-emitting diode, is a diode that emits light when a voltage is applied to it. As you can see, one lead on the LED is longer than the other. This longer lead is considered positive and should be placed where the voltage will enter the LED. Resistors are very common circuit components. They are often used to lower voltage levels and limit current flow through a circuit. Resistors come in many different sizes. The size of the resistor you are using can be found through the colored bars. Information on how to read resistors can be found online. In this lab, we will be using a button switch. This functions as a simple way of opening and closing a circuit. If the button is not pushed, the circuit is open. However, when the button is pushed down, the circuit is closed. A breadboard is a base for building temporary or prototype electronics. The breadboard is separated into different areas. How a breadboard is connected is important to understand. The columns of connection points seen on the left of the breadboard are connected vertically and will have the same voltage all the way down the column. The connection points in the middle of the breadboard are connected in rows of 5. The Arduino has many different connection points for attaching various circuit components. It can also supply 5 volts of power to a connected circuit. Today, we will be using the digital pins, which are labeled 0 through 13, the power pin, labeled 5V, and the ground pin, labeled GND. Other pins will be used in other labs. To have the Arduino unit perform a function, commands must be input into the device in the form of code. Arduino code is easy to use, and the Arduino website contains a large amount of resources for assisting you in understanding what each command means. Also on the Arduino website is a link to download the free coding software for use with the device. For the download link, please see the description below. This is the finished circuit. Your lab handout gives a description on how to build this on your breadboard. Notice how when the button is not depressed, the LED is off. When the button is depressed, the LED lights up until the button is released. The button switch is closing the circuit, which allows the Arduino unit to send a voltage through the LED. In your lab handout, the Arduino code for this experiment has been provided for you. You can see that it contains comments throughout the code which will help you identify what each section of the code is doing. However, we would still like to take a little time to explain a few commands and structures in a little greater detail. Integer, seen in the code as int, is how you will define variables and constants for this experiment. As you can see from the code supplied to you, it is used to define which pin the button and LED are connected to on the Arduino. Int can also be used to set variables to an initial state. Pin mode tells the Arduino code to consider a specified pin as either an input or an output. Digital read reads the value from a specified digital pin. This will be read as high or low. It reads high when 3 or more volts are present, and it reads low when the voltage measured is under 3 volts. The digital write commands writes a high or low value onto a specified digital pin. Voltage measurements are vital to understanding why an electrical component is or is not functioning properly. Voltage is measured in parallel to the circuit. In this lab, we will only be measuring DC voltage, represented on this multimeter with a V and a straight line next to it. Similarly to voltage measurements, resistance is measured in parallel to the resistor. However, it is recommended that you measure resistance while the resistor is not connected in the circuit. Measuring resistance is a fast way to check that you are using the proper resistors for a circuit. Unlike both the voltage and resistance measurements, current measurements are taken in series with the circuit. Taking a current measurement in parallel can damage and/or break your multimeter. If you perform this experiment and the LED does not light up, do not panic. Here are a few things that you should check. The first thing you should check is your LED. Make sure that it operates if it is supplied power directly. If it does not light up, change out your LED. Next, you should check the voltage of the button pin. If there is no voltage, you may have your button turned the wrong way. The third thing you should check is your code. Make sure the pin numbers correspond with how you set up your circuit. If the LED is still not lighting up, check to make sure you have the positive and negative leads of the LED in the right place. Finally, check the resistances of the resistors in the circuit. If the resistances are too high, not enough voltage may be making it through the circuit.